So I'm pleased to introduce Brendan Herger from Capital One. Brendan's the founding member of the Center for Machine Learning at Capital One and is helping his company to rethink how they use data and models. So he'll be presenting a talk entitled Automating Legal Fulfillment with SparkML. Please join me in welcoming Brendan.
Can you guys hear me all right if I skip the microphone?
Yeah.
Cool. I hate microphones. That's going to go off. Cool. Yeah, so let's go ahead and dive in. Can we keep the lights on, actually? Do you mind? Here we go. I don't want to fall asleep. Yeah, so my name is Brendan Herger. I'm a machine learning engineer at Capital One. I actually helped to found the group. If you want the slide deck for some reason, here's a link. There'll also be a link at the end, so you don't have to take pictures of every single slide. You can have it exactly as it is. It's also versioned because it's on GitHub, so if you want to see my process, you can do that, I guess. Before we get too far into it, let me give you a little bit of extra context. So, as I mentioned before, I'm a founding member of the Center for Machine Learning. We're an internal consultancy within Capital One, which means that we get to partner with all the different lines of business and all the different products within Capital One to rapidly build out and deploy machine learning solutions. Everything we do goes to prod, which is pretty awesome. It's also been really cool because 12 months ago there were 2 of us. Right now there's about 70, and by the end of next year we'll have about 200. So we're growing quickly, which is its own really fun area to be talking about. And as one of our early projects, we started surveying and seeing what sort of interesting natural language processing projects could we work on. And we found time and time again there were really heuristic, manual-intensive processes, usually focusing around getting some sort of a physical document, having someone read it, hand it off to someone else will read it, and you sort of hand it down the chain. Whether it's documents that you need to close escrow on a commercial building, or the process for subpoenas that we'll get into. There's just many of these really, really manual-intensive, very expensive processes that we could see building out a platform and actually starting to automate. Before I get too far into it, can I just get a quick show of hands? Who's familiar with the term naive Bayes? OCR? Happy hour? Hands went down for that last one. That's wrong. Yeah, so I know this is the very last talk. It's Saturday night. We're actually going to roll through this. This is a much abbreviated version of the usual talk, so we can get some booze and hopefully some questions. Cool, but it looks like modeling is okay. OCR maybe a little bit less of this. We'll dive into that as well. Specifically, we'll be diving into a use case. This was a 10% project of mine, so kind of a side of devs thing that I took up, helping a team in legal who go through this very manual-intensive process of getting, and this is legal again, so I think whatever was trendy 20 years ago is kind of what they've got now. They will get like physical mail, like buckets and buckets of physical mail. Open it up, they would sort through it, put it into physical like buckets, I guess, like things that you get from UPS when you have a lot of mail. And then people would read it and put sticky notes on it. And they're looking for very basic information, but there was a pain point because there was about 500 or 600 different unique formats that this text would come in, coming from a couple hundred different entities. So quick overview, what is a subpoena? It's basically a legal document where a court will say, hey, I need a thing from you as a servicer of Brendan Herger's credit card company or something like that. This could happen because someone's had identity fraud and the IRS needs to know, okay, what was actually this person, what was the fraud? This could happen because a business is having certain issues and a court needs to kind of go through it as part of the dissolution or something like that, or a million other reasons. And again, you're getting these documents from just many, many different sources, and on them use standard formats. The newest thing that they're actually starting to catch up was making sure that they're all typed out. So like some areas, I'm not going to point out who, will actually handwrite these requests and social security numbers, which is just all sorts of fun to deal with. But that's a quick overview, and we'll dive into that a little bit more now. So a quick look at how we're going to go through this. 3 main areas. We'll have an introduction, more into context about this particular project, an overview of the features that we've built out. Features here loosely translates to models, and then a Q&A, which will be a time for you guys to quiz me a little bit. Quick intro, I hate when people read off the slides, but this is a pre-prepared PR statement, so I'll go through it. Currently, Capital receives tens of thousands of subpoenas every year in response to them in a labor-intensive and heuristic decision-based process. What does that mean? That means that we had the opportunity as the machine learning team at Capital One to partner with our legal team and analyze their current process, which it turns out was highly manual, heuristic document sorting, triaging, information extraction. We actually, well, I sat down with these associates in Richmond, Virginia, and watched them as they took a document from one desk to another, and what they were marking up and kind of what their process looked like. We're replacing it with basically the same thing, with that word automated there. And that frees up a lot of human time, both of sort of lower QA and data analysis associates, but also very, very expensive lawyers to do more interesting things. And removing that pain point of dissimilar documents and using natural language processing to create a single uniform summary that's used for all of the incoming documents. Quick look at it. The best way to get through this is the architecture diagram. So we'll go down the left, or down the right first, and then kind of across in a separate slide. So the current process is that we'll get a whole bunch of mail, as I mentioned before, tens of thousands of pieces every year, highly seasonal, which is fun to deal with. And they actually just get bulk scanned now. So every document gets opened, it gets a divider sheet, and everything goes into a scanner. Then it lands on a secured network drive that's in current working space. We're in the middle of processing that, but it is very, very, very highly secure, so it's a very slow process to get something else that's like that. And then it goes through our enriching process. We'll dive into that in just a moment. After the enriching process, you get the original document, which is a fun 30 or 40 pages, mostly containing legal text and all sorts of crazy markup and fine print, and then also a convenient one-page summary. And it has a couple of high-value fields that most people actually care about. This alleviates tens of hours every week in terms of processing these documents. From there, it goes to an intake analyst who will triage it, put it into our system of record, and finally it ends up with an investigator who will say, okay, you know, this person from the IRS or FBI wants a set of information for this customer, and they go ahead and pull it. And this is the part that we're not automating yet, but we're laying the groundwork to automate in the future. Diving a little bit deeper into this, there's three main steps. It's an ETL platform. If you've ever worked with a pretty large data set, you're probably familiar with this. You'll notice that the title talk has the word Spark in it, and this architecture diagram does not have the word Spark in it. That's not an accident. We built out a proof of concept in Spark. It worked well, but it was just way over scope for what we needed it for, so we fell back to Python, which is much easier to deploy and would mesh better with our internal systems. So there's three steps, extract. So when you scan this document, you don't actually get a document in PDF like you guys are used to. You get an image, so actually like someone took a picture of it. So the first step is to perform optical character recognition, OCR. This will allow us to get machine-readable text, so mostly ASCII little UTF-8 representation of the words on each individual page. We used to have to do some conversion with GoScript. We've alleviated that step, so this is actually slightly out of date. And then from there, we use Tesseract. Tesseract is a really popular open source platform for taking raw text in a large number of formats and converting it to machine-readable text. And one of the really cool things about Tesseract, in addition to the fact that it works really well, is that you can get a confidence on the per-word basis. So if it's not sure about a word, it'll give it very low confidence. If it's very sure, it'll give it very high confidence. I'll bookmark that for later because that's very important for this use case. Additionally, we use the standard Python ML stack, so we're using core Python for an optical character recognition confidence with a regex search, and I'll dive into that in a moment. Also, we're doing some text processing with Natural Language Toolkit and LN2K, which is, again, pretty standard if you're in the Python realm. And then we're actually doing modeling using sklearn, another tried and true grade. There's obviously great opportunities in natural language processing to use LSTMs and recurrent neural networks. We looked at it, evaluated it. Turns out the marginal increase we got in accuracy was way overweighed by the increase in complexity. So at the end of the day, a very, very simple solution turned out to be the best. Finally, people need to consume the models that we produce, so we actually output two items. One is a YAML representation. YAML possibly stands for yet another markup language, possibly does not, depending on who you ask. But it's just machine-readable encapsulation, kind of similar to CSV, so that when we build further systems down the line, this is all incorporated. Additionally, we create a nice, pretty PDF using this cool system report lab that actually one of the folks who reports to me found out about. And it's just a really cool format for creating very easy PDFs in Python. So that's cool, that's the stack. Probably not where you're interested. You're probably more interested in the models. So this is a quick overview, and we'll dive into the actual models in just a moment. So there's a couple of main things that we're interested in. Lawyers really only care about one thing, risk. Bankers also only really care about one thing, risk. So the first feature that we built out was risk bucketing. I won't go into what delineates moderate and high risk. There is no low risk. Apparently lawyers don't understand low risk things. It's just like not in their vocabulary. But they have moderate, high, and then there's an ultra high risk, but that doesn't matter because those actually get delivered in person and the person waits while we fulfill them, so it sidesteps this entire process. So yeah, we built out a model there, and it turns out that the IRS will always say that they need something the very next day. So you could receive a mail, I don't know what the date is today, I think it's the 5th. You could receive mail on the 4th saying that it needs to be done on the 3rd, which is great because you should have done it already. It's very easy. And you can't always trust what people say in terms of high or moderate risk, so we actually had to look at some items in the text that are better indicators of the level of risk. Additionally, there's NA-Serve for weird legal reasons. Capital One has many financial products, and for weird legal reasons, each of them are kind of distinct entities. So our credit cards for customers like yourselves, and credit cards for companies, and auto finance and home loan and commercial are effectively separate companies for serving records like this. And it turns out if you serve something to Capital One Bank, and you really want credit card records, the bank just has to give it back and say, no, we're not them, please try again. One of the fun things that I found out, over the course of dealing with lawyers for a couple of weeks, they're very particular about wording. So we pulled that out, and it turns out we could do a very coarse filter that says, like, are they asking for bank records? Yes. Are they asking the bank for it? No. And that removes a whole bunch of work very high up. And it's a coarse filter, but it works really well. Additionally, there's document types, so we'll have specialists who deal with grand jury, credit verification, witnesses, summons, just different types of forms that you go through. Again, I didn't know any of this before I started dealing with lawyers. It's been a lot of fun learning about. Basically, anybody who wants to work for the federal government has to send out these requests to all of their banks, and all of their banks have to say exactly what's going on with their finances. So if you want to work for the government, keep that in mind. There's also customer identifiers, and these are high value. So these are actually the foreign keys that we use to look up into our systems of record. So standard things that you might get, like social security numbers, EIN, which is like a tax identifier, an account number, and basically anything else you can think of. So also date of birth is a fun one that will come up. And these come in all sorts of crazy formats. I didn't know that you could use DOS to separate social security numbers, but some people do it in addition to long dashes, short dashes, spaces, any character you can want. So that was kind of fun to normalize. So this is a quick overview of what we built out. Let's dive into how we actually did it. The biggest tool here was Naive Bayes. I'll let you guys raise your hands, so I'll kind of skim over this pretty quickly. But we built a pretty straightforward pipeline. This is actually a reusable pipeline we've used on a couple of different projects. So Naive Bayes is a machine learning algorithm that is mostly based in natural language processing. So it's very, very common anytime you have a very large feature space. That is, you have a very large set of things that you're looking at. Usually when you deal with text, you consider each distinct word a member of your feature space, and there's many different kinds of words in these documents that have a very large feature space. We'll take the text in, we'll do some tokenization, which means that we basically break up, pull out individual words. From there, we'll do lemmatization, which is a lot of text normalization. So we don't actually, this is just sort of the canonical example, it doesn't come up in legal a lot. We don't really care if you say runs, running, or ran. The core concept there of someone performing the running action is about the same. So we'll map all of those words into one similar word, and a couple of other normalizations. So if it's a plural, we'll just make it singular. And this gives us a smaller space to model with, and removes kind of a lot of the confusion around writing style. We'll additionally strip out stop words. So stop words are common words, usually in the English language. They're things like the, a, and, that are more indicative of writing style, which is a fun, different thing to model than they are of the actual content. And the legal domain, being what it is, actually has its own set of stop words. So there's a lot of Latin words that just get thrown around because you can and don't really mean anything. So we strip those out as well. From there, we build a pretty straightforward pipeline in sklearn. We use hyperparameter selection, grid search, and cross-validation to make sure that we're getting great results. Can't really say what my accuracy is, but it was 30% over what the client was expecting or really needed, so it was not bad. And then we go through a standard metrics evaluation. So not only do we care about accuracy, but there's very specific issues of precision and recall, certain cases that we have to get right all the time, certain cases that we can be a little bit more flexible about. And that's one of those fun things that nobody tells you about in grad school, where you build a model and the metrics are great, but really, like, the customer only cares about getting this one kind of subpoena correct, which is kind of fun. Additionally, we built out another feature that was regex with OCR confidence. This is unique. If there's a package that does this, please let me know. Otherwise, we're likely to open source it. It's something that was very specific to this domain, but it's kind of usable. So in many cases, it would be better for us not to give a social security number than to give the wrong one. If for some reason the ink got smudged or something, and a 5 turned into a 9 or a 1 turned into a 7, and we do a forward key lookup into our database, if the social security number ends in 1234 and we type in 1239, it's not going to come up. So we'll show that we don't have that customer, which is a very, very large pain point and actually a pretty large liability for us. So the way we built it out is we'll pull out things that look like, for example, social security numbers or account numbers, as well as the OCR confidence, so our confidence that those characters were correctly transcribed from the original document. Not very hard to do. It took about a day and a half, but it's actually been tremendously helpful for a couple of projects we've had. And so I'll walk you through it just because I wrote it and we've got a bit of time. So we actually, from the per word confidence, we'll break down the confidence for each and every individual character in the entire document. We get a table that looks something like index, the character, and our confidence in that character. We then join all of the characters and we'll do a regular expression search, which is pretty straightforward. And from that, we can actually get the start index and the stop index. So we'll go back to our big old table, we'll get the start index, stop index, and pull those out, and that's how we get the match. Then also, we've got these character confidences. So we can subset and get an array of the confidences for just the match that we're looking at. You can do a couple of different aggregations. For this use case, we're mostly looking at min, so it makes sense just to pull out the minimum confidence across all of that. But it's a pretty cool area. And that's actually most of the features. So we've built out this product. We're in the middle of deploying it, so we've had some very limited use. Now we're just understanding and iterating with the client to make sure that it works in their workflow. As I mentioned before, this is really just setting the foundation. It was a side of testing that I got to pick up and work on just across a couple of free days. But it's allowed us to drastically rethink the way that we use our legal associates' time and retask them to things that are more interesting, so not just shuffling through papers. Where the cool thing is it also lays the foundation for automating the process further downstream so that we don't have to have, again, very expensive lawyers or very expensive associates just keying in different document types or different customer identifiers into a database. We can start automating that process and freeing up their time to do more interesting things. And also reduce the risk around heuristic decisions and inconsistencies. With that, I'd like to make my shameless plug. I mentioned before that we've gone from 2 to 70 and we're going from 70 to 200. That was not easy. It takes a lot of time and it's been a lot of fun interviewing a lot of people. If this sounds like something that'd be fun for you to do, please reach out. We're hiring like crazy, mostly in San Francisco, but also in DC and New York. Here's my email if you're interested. Also, if you want the slides, as promised, here's a link to the slide deck. It's versioned on GitHub in case you particularly want to look at the versioning. And other than that, I'll open it up to Q&A and we can break for the happy hour soon. Cool, thank you. Do we have any questions? Yeah?
Yeah, maybe just more generally, what other applications have you seen for these technologies?
That's a broad question. These technologies in like text processing, or have I just worked on in general?
Yeah, you've worked on in general.
Yeah, so I've been very fortunate. I've been with C1 for C1 is short for Capital One for about 2 years. And before that, I was with a couple of startups while doing my master's in data science. So I've been fortunate to work on authorization fraud. So like when you take out your credit card and swipe it in a second or two, you get a decision, accept or decline. That's actually how most banks stop fraud, is we decline things that look like fraud.